I hope everyone has been having a good weekend. We're going to continue what we started in class. We did section 5.8 and we did 45.45 on Friday. And I'm going to do another mini lesson right after this one where we're going to do the 30-60-90. So let's go ahead and get started on a couple of quick examples. And we're going to do the same method that we did in class. Again, there's another way to do these, but the proportion way is pretty straightforward. And you're going to find for most of these problems it works out pretty easy. Later on in the year, and especially when you can move on through your math courses, you're going to discover other ways to do this. So proportions. Well, the way we want to set up this proportion is to think scale over actual. So we have scale, and I know my writing has always been terrible, but that's the way life is. Scale over actual. So we're going to compare apples to apples, orange to orange. This is my scale right here. And we showed how we proved that using a square and the diagonal and so on. And I'm going to compare apples to apples. We want to find the side lengths, basically these lengths right here. I know they're both the same because this is an isosceles right triangle. I didn't put that in there. I should have. There we go. And that needed to be right there. Okay. So we're just going to say we're going to find x. So I'm going to compare, say, 1 over x, scale over actual, is equal to radical 2 over 15. Use our cross products, which is just a shortcut for our reciprocal action. So we got 15 is equal to x radical 2. Do the inverse. I'm going to divide by radical 2 on both sides. That kills that. And now I have x is equal to 15 over radical 2. That is not my answer. We're not going to allow the radicals in the denominator. And that was a long philosophical discussion we also had. But for my class, we're going to simplify the radical and get it out of the denominator. We're going to multiply by 1. And 1 comes in many different shapes and sizes. And we choose radical 2 over radical 2 because this will cancel out the radicals. Remember, when we multiply radicals, radicals play with radicals. That's just radical 4. Radical 4 is the square root of 4 is nothing more than 2. So all this is going to turn into 15 radical 2 over 2. And we want to keep our answers exact. I'll talk more on that on this Friday as we get more advanced. But there's a lot of reasons why we want exact and some reasons why we want approximate. For this block, we're going to do a whole lot of exact answers. Next example. All right. So again, we're going to do the proportion method. And we're going to do apples to apples. Here's my scale. And here's my actual. And we're going to find the missing sides again. We know that these are the same. This is an isosceles. And we know these are 45 because base angles are congruent. Okay? So I'm going to put, well, looks like 1 over x, apples to apples, over radical 2 over 11 radical 5. Cross multiply. We get 11 radical 5 is equal to x radical 2. Again, we're going to divide, and we get 11 radical 5 divided by 2. That's radical 2. We're going to have to multiply by 1 again because we don't allow that radical in the denominator. So we got a radical 2 here, radical 2 here. And radical times radical, they do play together, so I'm going to have 11 radical 10. All over radical 4, which is nothing more than 2. 11 radical 10 over 2. All right, so that's pretty much it. Those are 2 examples. And we'll continue to practice this all this week before your quiz.